we've got the second in a series of two member forums organized by the Zero Carbon Committee. And so, Paul, if you're happy, do you want to give a brief introduction to this? And then we can kick it off with Mostafa.
Yeah, morning, everyone. Apologies for that. Just to follow up on Ian, someone's had a few gremlins this morning. So this is the second of our member forums. The first one dealt with more on the hardware side of things. We discussed the modifications to the cooler and preheater, etc. on the last forum. Mostafa, who is also a member of the panel, he has a presentation to give, a detailed presentation on energy saving opportunities on cement plants, and followed by Rosie then on the effect of AI. Then who else is Ian? Sorry.
And we have Zhang Lei from CNBM Group, who's going to talk about Industry 4.0.
Yeah. So with out for the delay, Mostafa, maybe let you kick the thing off.
Yes. First of all, I want to thank WCA, and I want to thank Ian, Rosie, and Joe for giving me this opportunity. Also, I want to thank Zero Carbon and Environment Committee and Paul for giving me the opportunity to share with you this energy management overview for cement plants, how cement plants can deal with energy management on the plant level mainly. For a cement plant, energy cost become. I will start my presentation with overview on what is the effect of energy management on cement plant. So energy cost in almost in all cement plant represents around from 40 to 70% of the total cost of cement production, depending on the plant context of which country the plant is operating, what is the energy costs in that country, how sourcing energy, and how the plant is managing its sources of energy, of course. But the importance of energy not even limited on reducing energy, not even limited on its cost impact. Of course, cost impact is the most important, but also nowadays climate change problems and reducing energy means reducing fuel or electrical energy consumption in the plant, directly impact the CO2 reduction initiatives in that plant, which is become also very important topic, and become with an cost impact in some areas in EU currently with CBAM implications. I think also emission trading systems in other countries is taking place, and it is an opportunity in countries where even where there is no emission trading system, there is some voluntary carbon markets cement plant can benefit from reducing its energy, capitalizing on its CO2 reduction to benefit from that context. For both countries where energy cost is expensive, or where energy cost is in other countries is not that much expensive, as I said, it become very critical for cement plant to reduce its energy cost. So energy cost reduction, either it is done on sourcing level, and it is not what we will talk today, or done on plant level utilization of energy, which we will try to share our experience in A³&Co for what we should do with WCA members, of course, so what we should do to reduce energy on the plant level. So this is our methodology. We believe that that understanding the energy usage in the cement plant is critical part. What is energy usage sources, energy consumers in cement plant, and how we tackle this energy consumers and what is the factors affecting this energy, and then planning for and organizing the cement plant team and focusing on the energy measures and what to reduce exactly with specific action plans, and the implementation of this action plan. And of course, monitoring and reporting is very important to always monitor your actions and its impact on energy. And at the end is a commitment to have this sustainable achievement of reducing energy in a cement plant. So this is the pillars, and for this slides, this is pillars in all over the cement plant, starting from raw material preparation and how consistent is the raw material, and how the raw material can affect the energy consumption, either the electric energy inside the raw mill or and it is impacting also as well the thermal energy inside the kilns. Of course, transportation have a part, utilities, compressors have a part of energy impact in the raw material preparation part, and also as well in the fuel preparation part, how we are managing our fuels, what is the mixes we have. Alternative fuels have some impact. All of this, the process itself, the process of the pyroline, inline calciner, pyroline, or air separate calciner, or whatever, the system itself, the cooler generation, all of this is affecting the energy. But whatever the system we have, and we can in each area we have some pillars which we can control, our energy consumption. Whatever the system we have, we should start with understanding the system. I will get somehow deep in the pyro line. So to understand the system consumption, first of all, what is the type of the system, and we can identify by very scientific methodologies for each system, for each installation, 4-stage preheater, 5-stage preheater, 6-stage preheater, and the system, the installed system, the cooler generation, first generation, second generation, or whatever, grade cooler. For this, we can have a reference number to start how much we should start from, and then we are adding impact of raw material, the raw material usage, and another impact of fuel if we are using alternative fuel, and the impact of if we have a bypass system or we don't have a bypass system, whatever in thermal. Then we are coming up with what is called the baseline value or thermal reference value, and this reference value is it should be the designed reference value. If we cannot identify this, or the plant is not having such tools to identify this, it can go back to, for example, its commissioning reference value, PGT value. And after we are getting this value, we start to audit our value on the continuous operation by auditing. I will come to how we are auditing, and this is in context for the thermal power. And then we will see in the next slides what is the pillars which might affect the thermal power consumption. But first of all, we need to understand our system. We need to set our value. And by setting our value, after we setting our value, we should put this target or budget value, which will consider also other factors like shutdowns, stoppages, every reliability of the plant or overall efficiency of the plant. All of these factors should be set, taken into consideration. Also, the same applies for the mills, either it is vertical or ball mill. We need also to start to understand our system and what is the reference values or the scientific value for our system. And it, of course, in mills, it will depend a lot on the product and the product mix. And then we are carrying after we get this scientific value, we are carrying an audit to know where we are from these scientific values. Going to after we understand our system and theoretical values, we should go to some practical measurements and audits, which we recommend to be at least done once per equipment, per kiln, per mill, per year. The audit measurement for kilns for thermal energy, for example, which is a focus part in this, to cover this covers site measurements, sample analysis of fuel, sample analysis of raw material, and data collection from the control room. So this is the detailed audit starts, and then for the site measurements, we should prepare for accurate kiln throughput weighment, gas analysis, O2, CO, and NOx in all over the plant, in kiln back end, in preheater stage, and in preheater outlet. Some flow measurements also, specifically in the preheater outlet before the fans and for the fans, temperature and pressure profile. So we get these measurements. At least we are recommending this audit, for example, to take place all over at least 24 hours, and measuring every parameter, burner measurement, the cooler fans measurement, at least 2 times during the audit period, so we are sure of the manual measurement results. Of course, manual measurement results will not be very accurate, but at least we are trying during the audits to stabilize all the parameters for 24 hours while measuring and weighing the kiln, and taking fuel samples and, as I said, raw mix and kiln feed and hot meal and product samples during the audit. Also, during for that audit, lot of data to be comparable with the audit results. So we are talking here about 1 year operation detailed reports, the utility data, the fan data sheets, and the equipment data sheets. So we can compare the design to what is happening inside the audit for 24 hours. And then the audit report should get deliverables with benchmark for the design values, and also with similar plants with similar equipment and similar fuel mix, some targets, also the cooler efficiency assessment for that plant, false air assessment in the preheater, fan efficiency assessment, and also power consumption assessment. this for understanding like that, we understand our energy usage, we measure our energy usage, and now we know, we can know the gap between the design or the standard or the reference value, and also the difference with other benchmarked plant. And then we in that stage, after that stage, we start to identify the actions. So the actions, normally this energy management actions should be within that context, either in thermal consumption or in power consumption. So the actions is always come from the audit results and comparison of the audit results with our designed and reference values and targets and OEM reference values, for example, and this actions. So the actions will contain, of course, raw mix actions, raw mix optimization actions, oxygen control actions, burner or fuel consumption through the burner optimization actions also. Cooler efficiency on cooler fans levels and operational targets, on grid speed under grid pressure and grid speed operation, and how we control this grid speed. Also on kiln speed, kiln O2, all of these actions will come out from the kiln dust, also amount of kiln dust if we have a problem in preheater or whatever. All of these actions will come out after we understand our plant, and then we make the audit. Of course, I don't want to make it only operation and production action, because okay, the audit has happened during 24 hours of stable operation. There is another part of actions, which is reliability of the equipment. Of course, heating up is taking a lot of fuels. Stoppages is affecting, or even the feed drops is affecting the fuel consumption. But the outcome will be also applying of standard operating procedures and revising the control loops and control parameters, automatic control loops, either in, for example, calciner control loop with temperatures, what is the optimum temperature to work on in calciner, and automatically related to a control loop, or cooler control loops, or even fans control loops. All of this is very important. And then we come to the, not the least, but the last part, as we are saying, it is cherry on top of the cake. After stabilizing this, we should start to think on digital optimization control through any expert systems optimizer, or through AI, which we'll talk later in the next presentation on it. But for the digital optimization control or AI control will not solve any process issues, parameters, or any mechanical or maintenance issues. This is what we are saying almost. We should first optimize our plant, get the maximum, and the digital optimization control is to stabilize and it give huge gains with this stabilized operation. Gains reach 5 and 10% in some cases. On the power consumption levels, also material composition is very important. Cement to clinker ratio, how to optimize cement to clinker ratio. The process fans in mills is and in kiln even is a huge power consumers, utilities, and ideal running where what equipment will be run or kept run during the equipment stoppage. If we are stopping a cement mill, what is other equipment which is running in that shop? If it is important to keep it running, or we can reduce this power, and also the electric network usage and the power factor optimization from electrical point of view. This is in brief most of actions we can tackle after we understand our system. And then we come to the monitoring part, which is also containing some automation part. And the monitoring part is very important. So on daily basis and on weekly and monthly basis also as well, we need to monitor our this levels. We need to monitor our power consumption, our heat consumption, our even our stoppages, our downtime, and even our feed drop analysis, quality parameters, all of this. So to have some reliable data and quick data and accessible and quick data, of course we are recommending to use some knowledge management systems or technical information management systems, and there is also a lot in the market who is providing these systems. And then either to like this plant, for example, which we are showing, is showing its data on a dashboard on BI tool, or even on Excel tool. The most important here is to identify the parameters you will monitor, and to have this data automatically on daily basis, weekly basis, and make energy performance management meetings and analysis to identify where are you from the target. For each plant, you can monitor this. This is one example for the thermal energy. You can monitor versus budget. Here 1% of energy consumption is considered around 400 megajoule per ton clinker. And here also you can monitor your alternative fuels, your fossil fuels consumption as well. Here, for example, also for electricity, it is for this dashboard, it is divided to raw mill area, kiln area, and cement mill areas, and they are tackling. This is a management dashboard where they are tackling the specific power consumption up to cement separately, and cement shop separately, and up to clinker separately. And they are comparing even the what is the budget power consumption, and the deviation of the budget is coming from where. So for example, budget up to cement is 97, and the deviation is mainly coming from power up to clinker is 3. Reducing the clinker factor is giving positive edge here in this plant versus their budget, of course. And cement shop is exceeding its target by 1 kilowatt hour per ton. So here it is very clear that we should go and see the power up to clinker, specify more. And when we go to the power up to clinker, we'll find that the raw grinding shop is taking 4 kilowatt hours per ton, exceeding its budget. So it is very important to have a target, to understand your consumption, and then after understanding your consumption, you are putting auditing and putting some actions to reduce that consumption, and then monitoring through either dashboards or any other types of data. Some activities which for commitment and follow up we are recommending also for cement plants. I think I tackled most of it, but in brief, is to define responsibility for the energy management according to each plant specific organization, of course, to develop skills assessment for key role positions in the energy management, the process rules, energy rules, what is define at least the skills you have in the plant and try to make it much more focused. Installation of technical information management system, of course, and establishing the follow-up, the daily and the weekly and the monthly process management, and even establishing some checklists, process checks within the cement plant. If you will audit once per year, you should also measure false air before and after shutdowns to see the impact of the work done on the false air in preheater, for example. Also to measure to make fan audits each one and there once per for the major fans, also once per year is recommended. To make some burner measurement to see the your burner momentum, what is the target for your burner momentum, and if you are exceeding or not. And also to monitor your, as we speak before, the cooler operation under great pressure, cooler exhaust fan, and your kill note. And at the end is to establish, as we said, the AI tool or the expert control system if you achieve a good level of optimization in your plant. This is management cycle, recommended management cycle, starting from daily cycle, daily monitoring, daily analysis of the parameters, to monthly and weekly action plans review cross-functionally, of course. As we said, it is a cross-function job, not only process and operation. Of course, process and operation are taking the lead, but it is a cross-function job. And then up to even some optimization or long-term actions, capex investment to have much more efficient on a yearly cycle basis. I have finished and I'm open for any question.